Good morning, class. Today I'm waking up in Tel Aviv, which is the largest city in Israel. Though it's not the capital, it is far and away the largest city. It's a very big, very modern city. Here you can see a view from my room. This is the north side of the beach in Tel Aviv. I actually took this last year when I was there, and it was a weekend, and there were people out sailing, as you can see. This shot is from the south, from a town called Jaffa, looking at the beach line in Tel Aviv. As you can see, it's filled with high-rise hotels, businesses, office buildings, etc. And there's just a marvelous waterfront that goes all the way along here with the promenade you can walk and run on. And there's a beach all along here where there's people out all the time, pretty much from, I guess, March through October. In the water, having a wonderful time. It gets a little chilly. Even March right now, it's going to be a little chilly while I'm here. But then it gets absolutely beautiful later in the year. And there's some waves and some surfing, and it's a beautiful spot. All right, well, good morning. I hope you're doing well. I hope you did well on your quiz yesterday. Let's take a look at today's word problem. This is one using scientific notation. Take a try. You've got exactly 2 minutes. Get started. Okay, 2 minutes is up. Here's how you do this problem. Um, Basically, it's a simple division problem. You've got 6 times 10 to the 9th people, a lot of people, divided by 1.5 times 10 to the 8th square kilometers will give you a persons per kilometer. The way you do this is you split up the 6 and the 1.5, so 6 divided by 1.5 is equal to 4. 10 to the 9th divided by 10 to the 8th is 10 to the 1. 4 times 10 to the 1 is 40. So 40 persons per kilometer squared. If you have any questions, just stop the video and you guys can discuss this. All right, let's move on to today's lesson. In Chapter 7.4, we begin the discussion of polynomials. Polynomial is a monomial, or the sum of monomials. We learned about monomials last week, and remember that monomials cannot have negative exponents. For example, a to the minus 2 is not considered a monomial, and therefore it's not a polynomial. A binomial is the sum or difference of two monomials. And a trinomial is the sum or difference of three monomials. So let's take a look at some examples and we'll see what they are. So 4y minus 5xz is a binomial. Each of those is a monomial, and that's the difference of two monomials. 6x minus 4 is also a binomial. 6x is a monomial, and 4 is a monomial. X squared plus 2xy minus 7, that's a trinomial. There are three terms there. And 14d plus 19e squared divided by 5d fourth has three terms, and each term by itself would look to be a monomial. But 5d fourth in the denominator, when you take that and put it in the numerator, that's a negative exponent. D to the fourth in the denominator is d to the minus fourth. When you have a negative exponent, it is not a monomial, and this term is not a polynomial. You would just simply write down nothing next to that if asked which of these it is. 26b squared, that's a monomial. 4a squared b cubed c to the minus 2 d to the fourth, it's nothing. You have c to the minus 2, a negative exponent. Now the next one's a little bit tricky. For the next problem, you actually need to do some combining of terms here, because you've got minus 3y squared minus 2y plus 4y minus 1. Now initially you would think that that's got four terms in it, but the first step you need to do is combine. And you can combine right here, minus 2y plus 4y, and get plus 2y. And so this term becomes minus 3y squared plus 2y minus 1. So there are now only three terms, and that makes it a trinomial. So the first step you need to do is combine like terms before you decide whether it's a monomial, or binomial, trinomial, etc. Okay, I hope that's clear. Let's move on. The degree of a monomial is the sum of the exponents of all of its variables. A constant has a degree of 0. The degree of a polynomial is the greatest degree of any term in the polynomial. So let's take a look at each of these, okay? 3a squared b to the third has exponents of 2 and 3, so that would be a degree of 5. 2a to the fourth, there's just one variable with an exponent, and that's got a degree of 4. And then x squared y. Now, at first you might think, oh, it's just x squared, so that's got a degree of 2. But when you have a variable like y and no exponent, we always assume an exponent is 1, y to the first. So that would have a degree of 3. So the degree of this trinomial is the degree of the largest term, which is 5. 5 is the degree of that trinomial. The next term, the next expression is a trinomial again. And we've got 3x squared that has a degree of 2. The next term, the x fifth term, so that's got a degree of 5. And the next term has a degree of 1, x to the 1. So again, the degree of this trinomial is 5. Okay, our third term, that is a monomial. And this monomial has x to the 1, y to the fifth, z to the 1. That gives you a degree of 7. Okay, and our last expression looks to be a trinomial, but as we look at that second term, there's a negative exponent. And so this, we just write down not a polynomial, and it can't have a degree. If it's not a polynomial, it doesn't have a degree. So you can take a look at that, take your notes, make sure you get this clearly. All right. The last thing we're going to talk about today with regard to polynomials is what's called the standard form of a polynomial. When you put a polynomial in standard form, you take the terms and you write them in the order of the greatest degree to the least degree. And when a polynomial is written in standard form, the coefficient of the first term is called the leading coefficient. So an example, 3x squared plus 4x to the fifth minus 7x, if we put that in standard form, the x to the fifth term has got the highest degree. That's got a degree of 5. So we'll put that first, 4x to the fifth. The x to the squared term, 3x to the second, will be our second highest degree, so then we put plus 3x squared. And 7x has a degree of 1, so that's our last term, so minus 7x. And don't forget to keep the sign in front of each term. And the leading coefficient is the coefficient of the first term. The first term is 4x to the fifth. The leading coefficient is 4. Okay, at this point in time, we're going to turn off this video that I've made for you today and go back to the SMART worksheet, and there are a lot of problems for you to do on the board or at your seat. If you go to the board, split up, stay quiet, and work on all the problems. There are plenty of problems here for the rest of today, and I'll be back with you tomorrow. Bye.